Right now, far beyond the orbit of the outer planets and well outside the Sun's protective influence, an aging spacecraft continues to communicate with Earth. Voyager 1 was never expected to survive this long. Built during the 1970s, long before modern computers, the Internet, or today's generation of scientists, it was designed for a relatively short mission. Its goal was to visit Jupiter and Saturn, collect photographs and scientific measurements, then slowly fade into silence. Instead, Voyager 1 refused to become history. It continued its journey into the darkness, crossed the outer frontier of the solar system, and eventually became the first human-made object to enter interstellar space. Today, from a region no spacecraft had ever explored before, it is sending back observations that challenge our understanding of what exists beyond the Sun's domain. The region outside our solar system is not the calm emptiness scientists once imagined. Instead, it appears active, turbulent, and surprisingly dynamic. Voyager has revealed a mysterious background vibration moving through interstellar plasma and a complex boundary surrounding our solar system that behaves less like a simple border and more like a constantly shifting shield. What makes this discovery especially important is that the same boundary Voyager crossed helps protect Earth from dangerous cosmic radiation traveling through the Milky Way. By studying this frontier from the outside, Voyager is helping scientists understand the invisible barrier that has quietly defended our planet for billions of years. When Voyager 1 launched on September 5, 1977, its mission seemed straightforward. It would perform close flybys of Jupiter and Saturn, capture detailed images, study their atmospheres and magnetic fields, and then complete one of NASA's most ambitious planetary expeditions. Everything changed after those encounters. During its flybys, the enormous gravity of Jupiter and Saturn accelerated the spacecraft, flinging it toward the edge of the solar system at tremendous speed. Instead of ending its mission, Voyager began an entirely new one. Throughout the following decades, it continued transmitting scientific measurements while becoming the most distant human-made object ever created. Then came the historic moment in 2012. Voyager crossed the heliopause, the outer boundary where the solar wind can no longer dominate the surrounding environment. Inside this enormous bubble lies everything shaped by the Sun, every planet, asteroid, comet, and every form of life humanity has ever known. Beyond it begins the true interstellar medium, a region controlled by the wider galaxy rather than our own star. Crossing that invisible frontier transformed Voyager into humanity's first scientific observer operating between the stars. Scientists had expected interstellar space to contain extremely thin plasma with relatively stable conditions. Although not completely empty, it was assumed to be fairly quiet and predictable. Voyager quickly challenged that expectation. Beginning several years after entering interstellar space, its plasma wave instrument detected a continuous narrow-band emission, a faint but persistent hum traveling through the surrounding plasma. Unlike short-lived bursts created by solar eruptions, this signal remained present over long periods as Voyager continued moving farther from the Sun. The discovery provided something researchers had never possessed before, an almost continuous method for monitoring the density of plasma between the stars. Previously, scientists could only estimate those conditions whenever powerful solar storms reached the outer boundary and temporarily disturbed the surrounding environment. Voyager transformed those occasional measurements into an ongoing record, revealing that interstellar plasma changes continuously rather than remaining uniform. Instead of a smooth background, the space between stars contains variations in density, shifting structures, and turbulence resembling a form of cosmic weather. Exactly what creates this persistent plasma emission remains under investigation. Some researchers believe it results from naturally excited plasma oscillations, while others suggest it represents quasi-thermal noise produced by charged particles interacting throughout the interstellar medium. Whatever its precise origin, the message is becoming increasingly clear. Interstellar space is far more structured and active than earlier theoretical models predicted. Voyager's discoveries did not stop there. Before completely entering interstellar space, the spacecraft crossed the heliopause itself, the narrowed transition where the outward pressure of the solar wind meets the incoming pressure of the surrounding galaxy. Scientists had expected this region to represent a gradual transition between two different environments. Instead, Voyager found an energetic and highly complex boundary. Charged particles were compressed, accelerated, and heated to extraordinary temperatures. Although there are no flames in space, this energetic plasma behaves so intensely that some researchers have informally compared the heliopause to a wall of fire. The comparison is symbolic rather than literal, but it illustrates just how energetic this invisible frontier truly is.